All right, so now we're gonna discuss the topic of angles and volumes. This is section 6, part 1 in your book, page 440. So this is 6.1, page 440. Let us first start with angles. An angle that is less than 90 degrees, we call it acute. An angle that is equal to 90 degrees, we call it a right angle. An angle that is between 90 degrees and 180 degrees, we call it obtuse. An angle that is 180 degrees, we call it a straight angle. And obviously the full rotation, which is 360 degrees, is called full rotation. Now, if you have two angles, for example, this is 40 degrees and this is 50 degrees, because the sum of the angles equals 90 degrees, we say that the angles are complementary angles. So let's say this angle and this angle, they form a 90-degree angle, then angle A and angle B are complementary. Now, if two angles form 180 degrees, so let's say angle A and angle B have a sum of 180 degrees, then we say that these angles are supplementary angles. This is the sign for angles. Let's say you have two angles. For example, this is 80 degrees and this angle is also 80 degrees. We call these angles equal angles, or we can call them congruent angles. In this case, congruent and equal, they mean exactly the same thing. Now, if you have an angle and a line cuts this angle into two equal parts, we say that this is an angle bisector. Bisector means it cuts the angle, or it divides the angle into two equal parts. If you have two lines that meet at 90 degrees, we say that these lines are perpendicular, and the sign for perpendicular is this. If you have two lines that do not intersect, we say that these lines are parallel, and this is the sign for parallel. When two lines intersect, this point is called the vertex. And what we need to know here is that these opposite angles are equal. We call them vertically opposite angles. So vertically opposite angles are equal. So this angle also equals this angle because they are vertically opposite. Now, if we have two parallel lines, and a third line comes and intersects them. How many angles are formed? How many angles are formed in this graph or in this picture? As you can see, 8 angles are formed. Now, how many of these angles are acute and how many of these angles are obtuse? Again, as you can see, 4 of them are acute and 4 of them are obtuse. So the 4 acute angles are equal, which means this angle equals this angle equals this angle equals this angle. And also the 4 obtuse angles are equal to each other, which means that this angle equals this angle equals this angle equals this angle. And one last thing you need to know is that if you choose any of the acute angles and you add it to any of the obtuse angles, so choose any acute angle and add it to any obtuse angle, the sum will be 180 degrees. Now, of course, we're talking about this figure. What is special about this figure, as I said in the beginning, is that these two lines are parallel. So whenever you have two lines that are parallel and a third line intersects, you need to know these three things. The 4 acute angles that are formed are equal. The 4 obtuse angles that are formed are equal. You choose any acute with any obtuse angle. In this figure, of course, we're not talking about any acute or any obtuse in general, but from this figure, you choose any acute with any obtuse, for example, and the sum of these two would be 180 degrees. And remember, we call this supplementary. What is the sum of angles? Sum of angles in a polygon. For example, let's say we have this polygon. We're going to draw it with 5 sides. 1, 2, 3, 4, 5. So this is a pentagon. And let's say that this angle is 68 degrees and this angle is 121 degrees, 103 degrees, 85 degrees, and we don't know this. We don't know what this is. Let us call it our angle X. So how can we tell what angle X equals to? The sum of angles in a polygon equals to n minus 2 multiplied by 180 degrees. What is n? N is the number of sides or the number of angles or the number of vertices. In a polygon, these are all the same. So in our case here, n is 5, which means that the sum of angles equals 5 minus 2 times 180 degrees, which is 3 times 180 degrees. So this way you can find what X equals to. So please remember to memorize this. The sum of angles inside a polygon equals n minus 2 times 180 degrees. Now that we discussed the sum of angles in a polygon, we're going to now discuss the sum of exterior angles of a polygon. What is the sum of exterior angles? So let's say we have this polygon. What are my exterior angles? So I'll extend this way, extend this way, extend this way, extend this way, and so on. So my exterior angles are the following: 1, 2, 3, 4, 5. Now, the sum of exterior angles in a polygon always equals 360 degrees, regardless of n. So it does not matter how many sides the polygon has. In any polygon, whether it's a triangle, polygon of 3 sides, whether it's a quadrilateral, a polygon with 4 sides, any number of sides to the polygon, this is always true. The number, or I mean the sum of angles, of exterior angles in a polygon is 360 degrees. Let's talk about similar triangles. What are similar triangles? Let's say you have 2 triangles. Let's say this is triangle A, B, C, and let's say that this is triangle D, E, F. Now, if I have one angle here equals another angle in the other triangle, and one angle here equals an angle in the other triangle, so because angle A equals angle D and angle B equals angle E, this means that the 2 triangles ABC and DEF are similar. So if you can prove or show, or it's given, that 2 pairs of angles are equal, this would help you reach the fact that the 2 triangles are similar. Now, I would remind you here that there is no point in them telling us that angle C equals angle F, because we know that the sum of angles here is 180 degrees and the sum of angles here is 180 degrees, because this is what the sum of angles in a triangle is. So automatically this would be true, right? So there's no need for this to be given to us. So now that we've proven that the 2 triangles are similar, how can I benefit from that? How do I benefit from the fact that 2 triangles are similar? In similar triangles, the sides facing the equal angles, have the same ratio. What does this mean? Let me explain what this means. Of course, you know what a ratio is. Now, how do I write these angles for these sides? I mean, for the first triangle, you can write them in any order that you like. For example, you can write EF, DF, and DE. So for the first triangle that you're writing here, first triangle, you can write the sides in any order, it doesn't matter. But when you come to your second triangle, you cannot write the sides in any order. You have to follow the same corresponding order, and this is what we're going to talk about now. What you do is the following. Because you wrote EF at first, you go to EF and you ask yourself, which angle faces EF? It's angle D. Which angle equals to angle D in the other triangle? It's angle A. Which side faces A? This is BC. I'm going to do the same with the other one. The second side that I wrote here is DF. So I go to DF and I ask myself, which angle faces side DF? It's angle E. Which angle equals angle E in the first triangle? That's angle B. Which side faces angle B? This is AC. Let's do it one more time. Although it's not really needed because the only side that remains is known. Anyway, let's try it. So here I wrote side DE. I go to side DE and I ask myself, which angle faces side DE? This is angle F. Which angle equals angle F in the other triangle? That's angle C. Which side faces angle C? This is side AB. So for example, let's say that it was given that BC is 6, AB is 10, although the figure is not very accurate, and AC is 7. And let's say it is given that EF is 18, and they ask us what is the length of side DE and what is the length of side DF. So here, you already know that EF is 18, and BC, EF is 18 and BC is 6. This is the same as DF, which I don't know what it is, divided by AC. I know that AC is 7. This equals DE. DE, I do not know what it is, divided by AB. AB is 10. This means that 18 divided by 6 is 3. 3 equals DF over 7, which means DF equals 21. And 3 equals DE over 10, which means that DE equals 30. So I'm going to repeat. To prove that two triangles are similar, it's enough to show that one angle in the first triangle equals another angle in the other triangle, and another angle in the first triangle equals another angle in the other triangle. This leads you to the fact that the two triangles are similar. Now that you've proven that the two triangles are similar, you can say that because the triangles are similar, the sides have the same ratio. But remember, you don't write the sides in any order that you want. For the first triangle, you can write them in any order you want. But for the second triangle, you have to follow the same corresponding order. This is why we said the sides facing the equal angle. So you have to write it in that order, in the order of sides facing the equal angles. And this would help you do what we did here, which is find the missing sides. Now let us talk about prisms, or you can call it a rectangular prism. So your base as well as your top are rectangles. So let's say that this is length L, this is width W, and this is height H. What is the volume? The volume is length times width times height. This is important for you to remember. And anyway, if you check your book, page 529, turn your book to page 529, you will see that in this page, which is given to you in the test, you have several formulas at the bottom of the page that are given to you. So the things that are written here, you don't need to memorize them because these are given to you in the test. So in a rectangular prism, we call this a vertex. So as you can see here, we have 8 vertices. This point is called the vertex, and this line is called the edge, and this thing that I'm gonna highlight in yellow is called a face or a surface, if you wish to call it that. Now, in a rectangular prism that we were talking about, sometimes they talk about surface area. Now, we already discussed the formula for volume. Now we're going to discuss surface area. What does surface area mean? Surface area means the sum of areas of all faces. So for example, if you have a tank and you want to fill this tank with water, now we're talking volume. But let's say your tank, you don't want to fill it with something. You simply want to paint it. You want to paint this face, and you want to paint this face, and you want to paint the 6 faces. If you add the areas of all the faces, this is what we call surface area. So let us draw this here quickly. This is called the top face. And this one here is called the base. So this is base, and this is top. Now let's say that this is width and this is length. Then the top and the base have the same area, and the area here is L times W. Let us look at the other faces. This is called the front, and the front equals to the back. This is the back. Again, assuming that this is W and this is L and this is H, then the area of the front or the back would be HW, because it's a rectangle, and remember, in a rectangle the area of the rectangle is length times width. We have 2 more faces to deal with. We have the right face and we have the left face, again assuming that this is W, this is L, and this is H. So the right or the left, each of them would be L multiplied by H. Now remember, we have 2 of each, 2LW plus 2HW plus 2LH. This gives me the surface area of my rectangular box or rectangular prism. Now, this is not given to you in the test, and you need to either memorize it or at least know how to analyze it. If you don't want to memorize it, it's fine, but make sure you know how to analyze it. Let us move to talk about a cylinder. This is a circular cylinder. We're going to assume that the radius is R and the height is h. The volume of a cylinder is the area of the base, pi r squared, multiplied by the height. This also you don't need to memorize it because it's given to you in the test. So make sure, as I said, you turn in your book to page 529 and you check all the formulas that are given to you so that you don't have to memorize it. So now we know what the volume of a cylinder is, but what about the surface area of a cylinder? What is the surface area of a cylinder? Let's discuss this a little bit. So here's my cylinder. How many surfaces does it have? The first thing I have is the top, which is a circle. And I also have the base, which is also a circle. And if this is r, then the area here is pi r squared, and the area here is pi r squared. Now remember, we're talking about the surface area of a cylinder. So if we think about the remaining surface, what is this remaining surface? It's this circular face, if you want to call it. Now if you open it, what would it look like? Let's say you get this circular face and you cut the side and you open it, it would give you a rectangle, right? So what still remains here, the rounded part between the top and the base, is actually a rectangle. Now of course here it's not in the shape of a rectangle because it's turned around, but let's say you open it, it would look like a rectangle. So if the height here is h, then this would be the same as the height here. We're going to call it h. What still remains for us to think of is what's the dimension here? What is the length of this side? Now, as we said here, if you take the circular part and you open it and you extend it, this distance and this distance are the same. And in a circle, what do we call this distance around the circle? Of course, going on the circle, we call it circumference, or we call it perimeter. And this is always 2 pi r. So this dimension is 2 pi r. So the area that I'm looking for here of this rectangle is 2 pi r multiplied by h. This would give me the fact that the surface area of a cylinder equals pi r squared and pi r squared. This is 2 pi r squared, and this area in the middle is 2 pi rh. Now, as I said before, make sure you know how to analyze it if you don't want to memorize it. You don't have to memorize it, but at least make sure you know how to analyze it. Let's go to sphere. Now a sphere is like a ball. For example, it could be a basketball or any kind of ball. We call it a sphere. The volume of a sphere equals 4 over 3 pi r cubed. And what is r? R is the radius of the sphere. Now, we're gonna see this when we talk about circles, but you either leave your answer in terms of pi, or you can say that pi is 3.14, and sometimes they give you how to calculate pi. Now, at the end of this section, which is angles and volumes, you have to do the homework from page 446, and you need to do numbers 3, 4, 5, and 10. So page 446, numbers 3, 4, 5, and 10. And this brings us to the end of this section, section 6.1 in your book, which is about angles and volumes.